Good morning. My name is Michael Kaiser. I'm the Chief Scientist and Professor of Fisheries Conservation at Heriot-Watt University. So thank you for giving me the time to make a small presentation to you today on the role of engineering and physical sciences in relation to the blue economy, with a particular focus on seafood production. So seafood production is a useful focus because basically we can take a cross-sectoral view from the net to the plate. If I start on this side of my diagram over here, one of the key innovations at the moment is, of course, renewable energy and the ability to store that excess energy in the form of hydrogen cells. Here we have a really interesting opportunity in Orkney to test the idea of decarbonising the capture sector by putting hydrogen cells on fishing vessels and thereby making them more profitable, but also reducing their carbon output. Once that product then passes into the supply chain, of course, we then can think about the transport links. So, for example, this lorry actually has a more polluting refrigeration unit on it than the emissions from the engine itself. So, again, there are some really interesting opportunities to decarbonise the food supply chain. Also, equally as important is the provenance of that seafood from the net through to the plate. And here there's great interest in the use of DNA barcoding, environmental DNA, and also blockchain applications to ensure that consumers have the assurance that the products that they're eating have not been contaminated by fraud or illegal fishing. Once we get to the processing sector, there are some major challenges, one of which is labour. Going forward, it's going to be increasingly difficult for the UK sector to attract skilled labour to process seafood. Here, robotics could play an important role in intervening and replacing people and also make the system more efficient and presumably much more profitable. At the end, we also have the issue of waste products. At the moment, much of this material goes into landfill. However, there's considerable interest in the idea of biorefining these waste products into products that can then go back into the supply chain in the form of packaging, which is renewable and also recyclable. Thinking about the actual science that underpins sustainable fisheries and aquaculture, there's an incredible role here for the engineering and physical sciences to play. So, for example, at the moment, using satellite technologies, we currently map where fishing vessels are around the world. Once we have this information, we can understand the footprint of fishing and we can ascertain what the environmental impacts are. And we can also use that information to predict the behaviour of fishing vessels in relation to management interventions such as the use of closed areas. It also helps us with surveillance to eliminate illegal fishing as well. There remains considerable interest in the idea of eliminating unwanted catch from fishing gears using a variety of disruptive technologies. So there's been a resurgence in the interest in the use of light and how we can use that to change the behaviour of fish in relation to fishing gear, and also considerable interest in the very innovative idea of using underwater robots to actually herd fish towards captured devices. In terms of actually getting data to inform sustainable fisheries science, that's a major challenge. Most of the world's fisheries are small-scale fisheries and data poor. However, by using relatively cheap camera technologies and laser scanning technologies, combined with artificial intelligence and machine vision learning, we can turn fishing vessels into scientific sampling platforms and actually deal with one of the many criticisms that fishermen have of scientists, that our data doesn't represent what they see in the ocean. And finally, we can think about bioengineering, whereby we combine food production systems with offshore structures such as renewable installations. And here we can actually generate increased food supply into the food supply chain through engineering of hard structures. But this is a challenge in its own right, given the robust demands that the marine environment places on any structure that we conceive. Hopefully, I've given you a few insights into the application of the physical and engineering sciences and why seafood production would be a good focus for such work. Thank you very much for your time.